Hi viewers, this video explains about the pop method in stack. So in stack representation we will have the structure with starting from zeroth memory location. So here earlier there is no data, there is no data 0. So now we are writing this structure with 0, 1, 2, 3, etc. This is n minus 1. Here n is capacity. N is capacity. Now, whenever we are trying to removing the element or deleting the element by using the pop method, we should check the stack is initially empty or not. So now the top value is representing -1. -1 means the stack is empty. So when we are calling the pop method from main method, so here you look at that we are calling the pop method from the public static void main. So now our elements are these elements in the stack, right? So for example, assume our elements are like here. Uh, first we are having 105, 200, 521, 51. So 51 here 500, 105 and one more element 200. 521 here 521, 200. Okay, these are the four elements in the stack now. So now we are checking, right, the stack is empty or not. No, the stack is not empty. So now the top is this one, top is this one, 51. 51 is represented by using the top. So when you are calling the pop method, the top of the element will be popping out from the stack. Popping out, that means removing from the stack. So for that, when you are removing the top variable will be automatically decremented by 1. Top equal to top minus 1. So the top is now new top is this one after removing the element, because always the top variable is notifying the top of the element in the stack. So now we are using the array variable is roll number, the index is top, so top is decremented by 1. Top is decremented by 1. So now the top is representing the 200. If again I am calling pop one more time, right, now data structure will be representation in this format: zeroth memory location, first, second. So here 105 is there, here 521 and here 200 is there. Now top is representing the second location. Then one more time, if I am applying the pop operation, again this top of the element will be popping out, removing out, right? So top is again decremented by top minus 1. So we are decreasing top minus 1. This stack name is now roll number. This stack name is now roll number. So now top is decremented, so top will be 2 minus 1 equal to 1. So this is the memory location. Now top value is representing automatically 200 is removing out from the stack. So here always we are accessing the top element to remove. So the time complexity is order of 1. Worst case also we are deleting only the top element of the stack. So order of 1. And space complexity, the constant time, we are deleting only one element at a time. So constant time, constant space needed for deleting single element. So space complexity also order of 1. And peak operation, the peak operation is returning top element of the stack. Top element of the stack. Okay. So here, suppose if our stack is having empty initially, the top will return the -1. So here the capacity -1 is the last location of the stack. So initially if stack is empty, our top value is -1. This indicates the stack is empty. So when now if I am calling the peak method, right, so this returns top value is -1. That means our stack is empty. Otherwise if I have the data 7 8 9, so now the top is indicating this top of the element 9. So whenever I am calling the peak method now, so this will return, peak method will return top element of the stack 9, top element of the stack 9. Here also the top variable accessing directly the top element of the stack. This variable is directly accessing the top element of the stack. So time complexity is order of 1, since we are accessing only one element to be removed or accessing. So here the peak operation is accessing only the top element, accessing only the top element. Space complexity also, we are accessing only one element, so we need only one space to store. Here also this is just accessing. Okay, then if you want to clear method, another method is clear method. If you want to clear entire stack, just we can represent the top equal to -1, so all the elements from the stack will be cleared. So this is the method which is representing inside the public static void main to access the top of the element from stack. So advantages and disadvantages when we are implementing the stack using array, which is very simple to implement because array data structure is very simple for usage. And the disadvantages, size of the stack is must be determined at initialization of the program itself, at the initialization of the program itself. Then if you are having the stack size is 100 memory locations, for example, if I have the stack size is 100 memory locations from 0 to 99. Okay, so here suppose if I use only the two memory locations, here 10 is stored, here 20 is stored, remaining 98 memory locations are wasted. Remaining 98 memory locations are wasted if we are using less amount of memory locations used than the declared size of the stack. And if the stack is once declared or initialized, we cannot store more than the size of the stack. You see, suppose if I want to insert 120 elements, but our stack size is only the 100, so we cannot store 120 data items into the stack because the stack size is already determined during the declaration itself with less size. Thanks for watching.